Hi, everybody. Today we're going to be doing a lab about stoichiometry. Stoichiometry is just a fancy way of talking about the amount of reactants that you need to make a certain amount of product and what the ratio of the reactants are relative to one another. So I like to use a metaphor of making bread. Let's say that we have 1 cup of flour and 1 cup of water, and I want to make all of it into dough. But with this ratio, I have a ton of water and I just have some flour that's floating around and making it starchy water. So I added another half cup of flour to my water, and now my dough starts to form, but it's still very watery. So add another half cup of flour. So now I have 2 cups of flour. And here I actually have a dough that forms. All my water has been absorbed, and I actually have some leftover flour because there's no more water for this flour to absorb. This is an example of stoichiometry. Here, I probably need a little bit less than 2 cups of flour for every 1 cup of water. Let's say I need 1.8 cups of flour for every 1 cup of water to have a full reaction with nothing left over. So at each step, we have a limiting reagent and an excess reagent. So here, we didn't have enough flour for the amount of water we had. So our water was in excess, and our flour was our limiting reagent. Then we added more flour, but we still didn't have enough to react with all the water. So again, our water was in excess and our flour was our limiting reagent. But at 2 cups of flour, we actually had an excess of flour, and now our 1 cup of water was our limiting reagent. That is the idea of stoichiometry. So let's talk about specifically what you're going to be doing today. You're going to be doing a double replacement reaction, which is whenever you have 2 ionic compounds that have a cation and an anion, and your cations just switch places. So A will switch places with C. It's a double replacement because both of these are being replaced. 2 double. So AB plus CD becomes AD plus CB. To make it more concrete, let's look at the reaction today. You're going to be reacting calcium chloride with sodium phosphate. So your cations are just going to switch place. Calcium with phosphate and sodium with chloride. So we make calcium phosphate and sodium chloride. Specifically here, we have a solid calcium phosphate and we have an aqueous sodium chloride. We determine whether something is going to be solid or aqueous based off of solubility rules, which you may or may not know by now. But you hopefully know this soon. But if we look here, phosphates are always insoluble so long as they're not paired with lithium, sodium, chlorine, or ammonium. So here, it's paired with calcium, so this is not soluble, therefore it is a solid. Sodium chloride, on the other hand, if we look here, chlorine is only insoluble with silver, mercury, and lead. It's soluble with anything else. So sodium chloride is aqueous, so it's not going to precipitate out. We know this intrinsically. If we add salt to water, it doesn't just sink to the bottom. It actually becomes broken up by the water. So the only product we're going to get here is calcium phosphate. So let's talk about your actual procedure for the day. It's very straightforward. You're going to be part of one of 2 groups. You're going to be either trials 1 through 3 or trials 4 through 6. In trials 1 through 3, your calcium chloride is constant and you're just varying your sodium phosphate. And in trials 4 through 6, again, your calcium chloride is constant within these trials and you're varying your sodium phosphate. So the only variable here is your sodium phosphate. What you're going to do is you're going to dissolve each reactant in its own glass of 20 milliliters of water. You will then combine the 2 glasses and you will observe the reaction. You should see something precipitate out. Make note of the color and consistency of that precipitate, as it will be useful later. You will then isolate the precipitate using a filter and a glass funnel. Afterwards, you will dry it in the oven, and then you will weigh the amount of product you got. And that's it. You just do that for all 3 trials. So let's discuss the questions you're going to be answering. So your first data analysis question is to consider why the mass of your isolated material, so what you took out of the oven, differed between each trial, and then consider what varied in the experiment and how that impacts your results. So have a discussion about that, why it varied, or in some instances, it may not vary at all. So explain why that is and think about the bread metaphor. Next, what is the possible product you can generate from this reaction? I already basically told y'all what that is, so make sure that you explain why that is the product that is made. And then you also need to say what observation backs that up, that is the product that is made. This is where the color and consistency of that product comes in handy. You should know a website at this point that should verify whether the appropriate product, calcium phosphate, matches with the color and consistency of your product that you made. Your final analysis question is, can you determine the stoichiometry of the reaction between sodium phosphate and calcium chloride? I do not care if you give me actual numbers here. For instance, I do not want you to just give me this reaction because I know you can just look it up. What I want you to discuss is doing this experiment, this protocol right here, could we determine the stoichiometry and why or why not? So you don't need to give me the actual stoichiometry, just explain how we know what the stoichiometry is or how we wouldn't know what the stoichiometry is. So that's your data analysis. For the next part, you're going to be making meaningful figures. So you've already done one lab where you made 3 tables. This lab, you're going to be making 3 figures. So for that, we go over to our meaningful figures page. So you can find a lot of information on how to make meaningful figures here. The first thing we need is a title. Ironically, these figures are missing titles, but you want to have a title that describes what your figure is. Next, we want to have our y and x-axis have labels, so pressure and volume versus pressure. Next, we want to have units, so what units are each of these axes? Fourth, if there is an obvious trend, put a trend line. If there is not a trend, please do not put a trend line in your graph. And then finally, you want to have error bars. So here they do not have error bars, but we always want to assume that we have a 5% error on all our data. So make sure you include those error bars when relevant. So for this lab, you're going to have to make 3 different figures. You must have all the features I talked about, or else you're going to lose points. Notice here, if you're missing error bars, you're going to lose half your points. So make sure you include your error bars on everything. So 3 different figures for this lab. It should be pretty straightforward. Make sure you're submitting figures and not tables. After that, you're going to have to submit an appendices. So this is going to be your raw data. So give all the raw data that you use to make the above figures and make it clear which raw data was used to make which figure. And the final thing you're going to do is you're going to suggest an experiment that will build on your data to determine the ratio of reactants to fully react. You don't have to do anything groundbreaking here. You can just do a simple addition to the procedure that was done in this lab. So just provide a suggestion. And that's it. Let me know if you have any questions.